Hi, this is Alex from devstories.eu, Zipline Backtesting Engine, Episode 4 of 7. Asset splits and dividends can instantly invalidate your price history. If a stock undergoes a 2-for-1 split, a naive backtesting loop will think the price just crashed by 50%. You avoid this by using the algorithm API and BarData interactions, which handle point-in-time adjustments automatically. In Zipline, the core of your algorithm logic interacts with an object typically named data, which is an instance of BarData. It gets passed into your event handlers, like your main data handler or your scheduled functions. Its primary job is serving pricing and volume data exactly as it appeared at that specific moment in the simulation, completely preventing look-ahead bias. When you call data.current, you pass it an asset and a field, such as price or volume. It gives you the most recent value available at that exact simulation minute or day. When you need a look-back window to calculate a moving average or historical volatility, you call data.history. You give it the asset, the field, the number of bars, and the frequency, like 1 day or 1 minute. Here is the key insight. Both current and history automatically adjust the returned data for corporate actions, but only up to the current simulation time. Your moving averages will not skew wildly on an ex-dividend date because the historical prices are adjusted to align perfectly with the current price frame. You get a mathematically continuous time series without having to manage the corporate action multipliers yourself. Before you act on that price data, you need to verify if the asset is actually tradable at that exact moment. Passing your asset to data.canTrade checks if the exchange is open for that asset and if it is actively listed. If a stock was delisted yesterday or has not held its initial public offering yet, this returns false. Next, you have data.isStale. If an asset is highly illiquid and did not trade during the current bar, Zipline will forward fill the last known price to prevent missing data errors. However, if you run a mean reversion strategy on forward-filled prices, you are treating on ghost data. Data.isStale returns true if the price you see is carried over from a previous period rather than a fresh trade. Checking both tradability and staleness before placing an order prevents a massive class of simulation errors. That covers inputs. Moving on to execution timing. By default, Zipline calls your main data handler every single simulation bar. If you run a minute-level strategy, executing complex rebalance logic every 60 seconds will slow your backtest to a crawl and trigger unrealistic transaction costs. The solution is the schedule function method. You use this inside your algorithm initialization phase to register a specific custom function to run on a precise timetable. It takes 3 main arguments. First, the function you want to run. Second, a date rule. Third, a time rule. Suppose you want to run a portfolio rebalance exactly 30 minutes before the market closes. You pass your rebalance function as the first argument. For the date rule, you use daterules.everydayHelper method. For the time rule, you use timerules.marketClose, passing 30 minutes as the offset argument. Now, instead of firing hundreds of times a day, your rebalance logic runs exactly once, right when the trading session is winding down. The separation between the BarData object for safe data access and the scheduling API for execution timing guarantees your core algorithm logic only runs when it should, using prices that actually existed at that exact moment in the simulation. I would like to take a moment to thank you for listening. It helps us a lot. Have a great one.